Hi everyone, this is SAT Practice, Similarity, Congruence, and Proofs. This is the medium set. And so read the problem. We have AC and BD are diameters of circle E, and we need to prove which, or show which triangle congruence theorems can be used to prove that triangle AEB is congruent to triangle DEC. So whenever you're asked to show that two triangles with the figure are congruent, let's mark up the figure to show which pairs of sides and which pairs of angles are congruent. Angles BEA, so BEA here, and CED are vertical lines, and vertical lines are always congruent, so mark this up. Also, several sides of the triangle are radii, so they are all equal. So basically what we have is these are all congruent. Here, 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 and here. And then the angles there are congruent. Notice that the angles between the two sides with hash marks are congruent. This lets you demonstrate by SAS. You have side, this is side, angle, side, that AEB is congruent to triangle DEC. So C is the correct answer. Okay. Next one. We have the right triangles are similar. What's the length of the shorter leg of the larger triangle? So let's write what we're looking for. We're looking for this, and they're congruent. So whenever you see a square root of 3 in a triangle, think about the special right triangles. And when you do that, you'll notice that this does look like special right triangles of 30, 60, 90, because this would equal your 2x. This would equal your x root 3, square root of 3, and so x would be 5. And then knowing that the two sides of the smaller triangle fit in this ratio is enough information to draw a conclusion. And you could also use the Pythagorean theorem. Alright, so we're going to do the same thing because these triangles are similar, and solve. We know that the side across from this, we know the side across from this is 2x. So x has to be, this x is going to be 15. And then this side here is going to be x square root of 15. Okay, so, which is not so, whoa. So basically what you're going to do is 2x is 30, so all we need to know here is this is 15. This side would be 15 square root of 3. So the answer is 15, which is B. Okay. So anytime you see the square root, try to see if it works with the special right triangle formulas. Okay. We have a triangle with sides lengths 5, 12, and 15. Is similar to another triangle. The longest side of the other triangle has length of 24. So what's the perimeter in centimeters of the larger triangle? So basically, corresponding sides of similar triangles are in proportion to each other. So we're going to set it up as a proportion to find the lengths. So we're going to do the shortest sides. The shortest sides, if this is 5 to 8, did it give you that? Alright, so the longest sides are a ratio of 15 to 20. So this would be the longest side of each triangle. Okay? Which is simplifies to 5 to 8. And so we're going to set up a proportions to the shortest side to the longest side. So shortest side, this is the proportion to longest side. So I'm going to put the longest side on this side. So this is 5 to 8. And 5 goes with the 5 here. So this is 5 to x. And then cross multiply. So you get 5 times 8 equals 5x. This is 40, or you can just divide by 5, so 8 is x. Now let's do the medium side to long side. So this was this one. Now let's do the medium to long side. So we're still going to have 5 over 8 here, and our medium is going to be set up to 12 here. 12 over x. And cross multiply, and you're going to get 12 times 8 equals 5x. So 96 equals 5x. So x equals 19.2. So now we have all our lengths of the larger size, and we want the perimeter. All this is already in centimeters. So we have 8 plus 19.2 plus 24. That equals 51.2 centimeters, which is C. Okay. The next one, we have two triangles that are graphed on a coordinate plane. Which of the following statements is true? And I didn't type this out, but basically they gave you the triangle MNP with the vertices here, and they give you triangle QRS with the vertices here. Okay, and we want to know if which statement is true. So are they congruent or similar, or neither congruent or similar? And I went ahead and took the liberty of drawing them here to save some time. So when you look at this, we're going to look at, let's see. Okay, so when you look at this, we're going to label it, and you might think it's easier to really quickly draw this. So notice that the triangles are not congruent, because one is bigger than the other. So we can eliminate the congruent part. Both triangles are right triangles, so they could be similar. So we're going to set up the corresponding angles to see if they're equal. So I'm going to set up 2 to 4 and see if that equals 4 to 9. And clearly that's not true. So basically the answer is D. So the triangles are neither congruent nor similar. Okay? And is that it? Oh, we have one more. Number 7. We have, and this was hard to type as well, so I went ahead and drew this. JK equals KL, so these sides are the same. And JL, where's JL? This whole length is 26. So the ratio of MN to MP is 8 to 5, and we need to find the length of the segment between J to M. So we want to find this length right here. Alright, so basically what we want to do is the given ratio involves the sides of two small right triangles. So we have triangle 1 and 2 here, 1 and 2. And the question asks about the side of one of those triangles. So focus on this. The base of the angles of triangle JKL are congruent because it's an isosceles. Additionally, angle JNM and LPM are both right angles, therefore they're congruent. Now when two pairs of congruent angles in two triangles are congruent, the third pair must be congruent. So triangle JMN, so JNM, this one, and LPM are similar. So this means we can do the corresponding sides of the triangles are proportional. So we know that Jm over Ml equals Mn over Mp. Okay, because Mn equals 8 over 5, it follows that Jm is 8 and Lm is 5. Alright, so basically we let Jm equal 8x. We're going to get Ml equal 5x. So we're just setting this with the x's here. Okay? And then you can just solve. So we also know that JL, which is the sum of the lengths of JM and ML, so these two together, alright, equals 26. So we have 8x plus 5x equals 26. Solving this gives you 13x equals 26, and x is 2. Okay, so if x is 2, then we have Jm equals 8 times 2. That part. So it equals 16. And this was a griddable. Okay, thank you. The next set we're going to do is considered hard, and we have 3 of those. Take care. Bye-bye. Have a nice day.